Thanks a lot, Dominic. Thanks a lot, Santosh. As already introduced by Dominic, my name is Tomasz Łyszczyk, but just call me Tomek. Like Dominic, I'm a trainer and content creator at Altcom Academy. Today, I will have a privilege of telling you a little bit about zero trust security model and especially when applied to cloud workloads. Both Santosh's and Dominic's talks were through the light of an EC Council's offering, a training that you can take part in via Altcom Academy. The talk I'm delivering is more generic. However, it is a little sneak peek into one of the newer offerings by EC Council, something called CCSE, standing for Certified Cloud Security Engineer. This course is, as far as I know, is not yet offered by Altcom Academy, but hopefully it will be offered soon. So just stay tuned if anything changes. Now, without further ado, let's focus on the good part. Zero Trust Cloud Security. Let me give you some background of why is this even a thing? Why are we gathered here talking about this security model? It all has to do with our way of working. For the past perhaps even 100 years, people were working in a so-called traditional work model. However, recently, the pandemic and the digitalization of the workplace moved us more and more towards the remote work model, working from home, working from the middle of the forest, being on vacation while working. It can take multiple forms, but we are not in the office anymore, at least not so much. It can be something in between, working in a so-called hybrid model, let's say 3 days in the office to work 2 days from home, and so on. And this change in the work model actually might be one of the biggest changes in how we work since perhaps even industrial revolution. In the USA, we can observe something called Great Resignation, people changing jobs, people wanting to work from home, and employees even quitting jobs when employers ask them to come back to the office. So it looks like this new remote work model is here to stay. For sure, it will evolve and we will also adapt. Perhaps some of us will get tired of working from their own bedroom, like I am. But in general, I think we need to get used to working remotely. So now, how it used to be. The traditional work model in general assumed that we had some core business hours, some core working hours that we adhered to, typical 9 to 5 or something similar. In general, we used to work from a single physical location, from an office that we had to commute to, then we had to commute from, but we were not at home, we were at the office. Apart from us being in this same physical location, all of our so-called workloads, so the company's infrastructure, data servers in the data center, racks, network devices, whatever that might be, it was also there. It was a centralized physical location, so-called on-premises. And then we worked on our laptops, our workstation. This hardware was all company issued. We were not working on our privately owned devices. If we had a workstation, if we had a laptop, it was provided to us by the company. And as such, it was managed by the company in some kind of mobile device management solution. In most cases, we were joined to a domain, at least in a Windows environments, in a Windows solutions. which is still the case. However, nowadays we might also use our own devices in a model called bring your own device. From the security standpoint, the traditional work model was it wasn't necessarily better, but it was definitely easier to manage by those in the company responsible for the security. If everyone worked the same business hours, if everyone was at the same place physically, it was easier to enforce some security rules, some security policies. And the traditionally used model in this traditional work model was something called perimeter-based security model, where at the very center of things, we were securing our data as the most important asset of the company, information. And then gradually going, let's say, outside, we had our applications using processing these data, our infrastructure, so physical hosts as well as the network perimeter, network devices, servers, so on, up to or even down to the cables themselves. All of this was contained in a bubble of some sort called our perimeter. And here the primary rule of thumb was that everything inside the perimeter is trusted, is safe, should be secured, and in general has open access to everything else that is inside. At the border of this perimeter, hence the name perimeter, was our external security measures, and everything that was outside this perimeter was considered hostile, was considered a threat. This is the place where we had those black hat malicious hackers trying to get access to our environment. And as I said, from the security standpoint, for administrators, for security engineers, this was easier to manage, easier to handle, even because of this centralized one physical location. So the hosts were inside the perimeter. Network devices were inside the perimeter. Users physically were in the office. They were inside the perimeter. And to give you an analogy, this was like coming back home. The only place where we have to, let's call it, authorize and and authenticate ourselves is at the front door. We need to have the key, or we need to ask someone that is home to let us in, someone from our family, and then once we are inside, we have free access to each room. We can go to the kitchen, we can go to the bathroom, we can go to the bedroom. No further questions, no more showing ID, no keys that we have to use inside our own home. This is our internal zone inside the perimeter. And inside we are a trusted asset, a trusted user. Anyone outside our home, on the second side of the door, can be considered hostile and not trusted. And this is a typical behavior for us, trusting something that is inside, that is known. Hence, it was also employed for the reason of securing our work environment. However, with the massive rise of this remote and hybrid working model, all of those rules, all of those principles were broken. Now we are working flexible hours, no more strict 9 to 5. Someone can log in and access company assets in the middle of the night, because hours are flexible. We are no longer working from a single centralized physical location. Now we are working from home. We are taking our laptops with us when we go on vacation. So it's harder to physically secure. company's assets. We are working on our own devices. They are not necessarily company issued. Even if we have one that is company issued, in most cases we can also log into to company assets from our own PC or from our own mobile phone, which may or may not be enrolled into the MDM solution, the mobile device management solution. And as such, a company does not necessarily have influence on what we can and cannot do on the device that we are using. It is a good practice to divide our work activity from our personal activity, not to do both of those on the same device. However, in reality, most of us will at least sometimes log into some company portal or even check a company email account on our private device. Finally, while in the traditional work model, when we had offices, a lot of our infrastructure was on premises. So in these offices, right now, a lot of workloads are deployed in the cloud. And even though there are, at least from the cloud vendor perspective, these are centralized locations, these are specific data centers located all across the world. However, from our company's point of view, this is not the office. The database we are accessing, the application we are using, is neither at the office nor locally at home from where we are working. So all of those reasons make ensuring security that much harder. And here enters, in comparison to perimeter-based security model, zero trust security model. And in a nutshell, if you don't want to dive into specifics and details, zero trust model has one single principle: trust no one. Getting back to this home analogy, in the perimeter-based model, we only had to authenticate and get authorized at the front door, and then we had free access to each room. If we were to imply zero trust security model at home, this would mean authenticating and authorizing before entering each room. So it's not enough that we had, let's say, a master key and entered our home. Now we have to also show our credentials, show that we are permitted to enter into the kitchen. We need to get authenticated and authorized to get into the bathroom, and so on and so on. It's we are no longer a trusted entity inside the perimeter. Actually, a sneak peek into slides that will appear later. There is no perimeter in the zero trust security model. So there are no trusted assets inside, and there are no malicious or considered malicious assets outside. Everyone is considered malicious, everyone is considered a potential hacker, and we have to authenticate, authorize those entities every step of the way. Why should we even worry about authenticating and authorizing everyone every step of the way? Nowadays, most common attacks fall into one of those categories. It's either ransomware, typically rolled out by APT groups using Cobalt Strike solutions or other more elaborate, more advanced frameworks. Supply chain attacks, typically when we have projects using technologies like Node.js, JavaScript frameworks, relying on tons and tons of dependencies. Some of those dependencies are open source projects hosted on GitHub that either contain a vulnerability that wasn't previously discovered, and now we don't know about it as well, so we are using a vulnerable dependency, or the project itself can be compromised, some malicious code may be injected, and we unknowingly download this dependency, and hence we are using a malicious package. So these are, let's say, external threats to our company. However, we may also face an internal threat in the form of a, let's say, disgruntled employee, someone who is not happy about working in our company, or someone who wasn't performing very well, and we decided to let him go. And in this final few days before leaving the company, someone decides to break some stuff just for pure malicious reasons. If he's working from home, it's that much harder because he doesn't have a physical access. However, it's also harder for us to detect those attempts of doing something, of breaking something in our environment and preventing it, obviously. So the zero trust security model, the general rule is very simple: trusting no one. However, we can elaborate on that, and we can differentiate 5 core zero trust principles that we should enforce when we want to end up with a successful zero trust security model implementation. First of all, we need to understand that there is no perimeter, there is no inside and outside. And as such, there is no trusted and not trusted and malicious actor. Everyone is it's like in a US court. You are considered guilty until proven otherwise. The same applies here. You are considered malicious until proven that you are safe. We authenticate entities every step of the way. We ask for permissions, so we enforce proper levels of authorization also every step of the way. And then we enrich our decision-making process with contextual information. So it's not only credentials, it's not only username and password. We also check other things to prevent some malicious actions in our environment. And all of those steps combined into a validation process, we perform those continuously. So it's not like we authenticate and authorize only once, and we are granted access for, let's say, the whole day. It doesn't work like that. We need to get authenticated, authorized frequently, and this validation is performed very frequently. Some tenets or some more detailed security rules about zero trust, some points to focus on when planning a zero trust implementation. All data sources and all computing services are considered resources. In comparison to the traditional, the perimeter-based model, we might have thought that some assets, some resources are company-owned and should be secured. Some other perhaps we even thought that they can't be hacked, that they are safe for some reason, and they were not onboarded into our security solutions. They were not considered important. In Zero Trust, everything is considered important. First of all, because it can enrich our decision-making process. Second of all, because we assume that we can't think of everything that the surface attack is so wide that everything in our environment should be taken into account. So hosts, infrastructure, workstations, users themselves, entities, data, endpoints. We will cover those elements in more detail later. The most important thing is that everything can be important. Communication should be secured regardless of network location. As explained earlier, we do not have inside and outside the perimeter anymore, so the communication can come from different places. We might be in the office, we might be physically plugged with an Ethernet cable to the local network. This communication should be secured. On the contrary, we may be using a mobile connection from the other side of the world, lying on the beach under the palm tree. This communication also should be secured, regardless of the place of origin. Each access to resource should be granted on a per session basis. So it's a single access granted only for a specific period of time. And if we, let's say, log out of some session, then if we want to log in again, the whole process is performed again. This whole validation is performed again. There is no trusting someone for an extended period of time. Those resources that we access and access itself in zero trust model, as I said, is not based only on username and password, only on having credentials. The decision whether we can or cannot access something is dynamic. It is based on, as stated here, so-called observable state, both of our account, our user entity, also the application and service that we are trying to access, and external contextual information like environmental attributes and our behavior even. This behavioral analysis, so-called UEBA, user and behavior analytics, is a very powerful tool for detecting threats in our environment simply by detecting anomalies in our behavior. Monitoring, that's the foundational part of any security model if we want it to be successful. We know, we've already said that all resources are important. Now all of those resources need to be monitored. The more logging, monitoring we have enabled on our assets, on our workloads, the better, because it will give us more insight into what is happening, and it will be also useful in a post-incident analysis, even if we were compromised, to get to know what actually happened and how our company was compromised. Authentication and authorization every step of the way, they are also dynamic and may be enforced with some additional ifs and elses, some additional conditions, for instance, depending on our physical location. And it's a very common use case to, for instance, ask for a second factor in an authentication process, which should be enabled. By the way, we all should use multi-factor or second factor authentication, however you want to call it. And in zero trust cloud solutions, it's common to ask for a second factor if we are in an unknown location, whatever that may be. It is for us to establish what can be considered an unknown location. But for instance, don't ask for a second factor if we are in the office. And if it was established that our connection can be trusted based on other factors. Logging and monitoring, we've already covered that. This is for the contextual information, also in general for improving the security posture. Some companies and organizations, based on those zero trust security tenets, so those principles and rules, develop their own guidelines on how to implement this model successfully. Here we have a set of guidelines and rules from National Cybersecurity Center. These are more or less the same as the tenets we've just covered. So identity and access, identity management solution, this is something that wasn't specifically stressed yet, but should be a core component of our solution. I will show you after the slides. I will show you how it can be done in Azure Cloud. What is the resource and what functionalities it offers. We authenticate our users. We authenticate machines. This is also important. Not only us as users have entities, have identities, and not only we log into somewhere, not only we use some services, machine-to-machine communication is equally important. It can also be compromised and leveraged to compromise our environment, to extract some data. So machine-to-machine communication should be also secured. We gather and use contextual information for be it for policy compliance, for device health, for logging and enforcing some procedures. And we apply fine-tuned access control policies even within the application or for a single resource, depending on the circumstances. The most important components that we should focus on when implementing a zero trust security model are first and foremost identities. These are identities of us as users, but these are also identities of hosts and servers in general in our environment. Endpoints would be the devices that we use. So those either company issued or our own devices that we use for our daily work, including mobile devices, smartphones, if they are used. Data, also at the very core of our solution. So the databases, SQL, NoSQL, whatever that might be, both from the infrastructure point of view. So let's say the SQL server itself, but then on the server we have the database, which should be also secured. Finally, data in the database, in the tables. Also, there are some mechanisms that we can leverage to increase the level of security. Things like encryption, obviously, data masking, preventing access to the data, even by the employees, by the developers interacting with the database. Securing applications, so monitoring logging, monitoring actions in the applications by the users. Finally, infrastructure, including network infrastructure, so all of the traffic in our environment, both coming in, both going out, should be monitored, filtered, analyzed, and threats might be detected just based on that. Here we have another few examples of what can be monitored. As I said, identities, both human and non-human, so both us and our servers. Applications, both those deployed on premises, if we are in a hybrid environment, so some of our environment is on premises in the office, some is in the cloud. That is a so-called hybrid solution. everything that is infrastructure as a service, platform as a service, software as a service. Finally, doesn't matter if it's an application; it should be monitored. Data, both our data, credentials, and data stored in the database. In terms of identity protection, some best practices, some hints on how can we increase the level of security. We might decide in our company to disable logging in from mobile devices. It's a simple rule to enforce that will not impact, that should not impact our company from the business point of view, but will definitely increase the level of security. Disable logging in from certain geographies, certain locations, countries all around the world. This also makes sense. It's easy to spoof, on the other hand, but if we, let's say, have offices only in Poland, we don't expect our employees to log in from anywhere else other than Poland, then we should be good to just disable logging in from any location outside our country. Detecting compromised credentials, this is something that is also out of the box in a lot of in those major cloud providers, being Microsoft with its Azure offering, Amazon's AWS, and Google's GCP, Google Cloud Platform. So the identity and access management solutions in those clouds offer by default looking in the darknet or dark web for our for hashes of our credentials, basically. Disabling an account after multiple MFA failures were detected. This is also a very common use case where if we do not confirm an MFA request, for instance, on our mobile phone, then the account will be locked, which in turn prevents compromise of our account and perhaps compromise of some more environment as a result. Enforcing under certain conditions, we've talked about that, where we can decide not to enforce it under certain circumstances, or the other way around. If we, let's say, detect a login attempt from an unknown geography, we may add an MFA step in this case. This continuous verification I also talked about. This takes into account contextual information on one hand. On the other hand, it also takes into account risks related to current action. So let us focus on this login attempt from an unknown location. If it is assessed by our solution that this is a high risk location known for some malicious actors, then the risk will be higher and the MFA will be enforced. If the location, the country that we are logging in from, isn't on any kind of red list or something like that, then it may be considered only a medium level risk or even low risk action, and MFA is not enforced. And it's a dynamic process. Decisions are taken, let's say, live while we are doing some actions. Limiting the blast radius is also a very good practice, regardless even of zero trust or not zero trust, cloud or on premises. This is a good practice in general, where we should use accounts with least privilege that they need to do a data job, and also divide our environment, whether from the network point of view or from the logical point of view, into segments, and then our account should be only allowed to perform actions within a certain piece of this environment, so that when we are compromised, not everything is compromised, but only this small piece. That's why we shouldn't use our administrator accounts, our global admins, things like that, on a daily basis. Those privileged accounts should be accessed only temporarily, for us to do a specific action, and then we should log out of them. And also the scope, so this piece of the environment that we have access to should be limited, to only to what we need to have access to. The contextual information, I mentioned earlier, this can be anything from our entity, whether we are a real user or a service, to number of connections that we are making, to the location from which we are making those connections, the hardware we are using. This device footprint can be useful when detecting a threat. Firmware version, geolocation, I already mentioned. All of those are taken into account when deciding whether to give us access or not. OS, we are using applications that are installed on the device we are using. Perhaps we have a history of incidents. Our account has a history of incidents that we were part of, which also influences our account's risk level. If we have never been in any security incident, then we basically have a clean slate and are not considered, are not restricted in any way yet. However, if our account was compromised once, even if it was a long time ago, we may have this in our history, and some more restrictions are applied. Perhaps it was decided that we are some kind of VIP user, CEO of the company, or an admin with higher privileges. And since we have so high privileges, restrictions are also stricter, and those apply to our account. We've talked about logging and monitoring. For this, we will use some kind of CM solution, security information and event management. On top of CM, it would be good to use a SOR, security orchestration, automation, and response tool. At least in the cloud, these operate very tightly together. It can be even a single tool capable of both gathering logs, so the CM part, and then analyzing, creating security incidents, and then responding automatically to those incidents, so the SOR part. Regardless if it's Azure, GCP, or AWS. On premises or on endpoint devices, we should roll out some kind of EDR. For instance, a CrowdStrike Falcon solution already mentioned by Dominic, all with the goal of automating incident response, which was also covered by Dominic during his previous talk. So I'm not going to double down on that. Some example use cases that might be discovered in the cloud environments. Mass file download from SharePoint. Here, let's imagine that we are a regular user. We work with SharePoint, or we work with OneDrive, Dropbox, services like that. And during our daily job, we download 2 files, we upload 2 files, edit something. This is our average. But once again, suddenly our account logs into this SharePoint service in the middle of the night and downloads 20, 50, 100 files. this is something that isn't common for us. And if we are monitoring this service, if we are monitoring what my account is doing, then we will detect an anomaly, an outlier, something that is far from regular, far from normal, which can be flagged as a security incident. And it might be a false positive. It might be really me logging in the middle of the night and downloading something because tomorrow I'm going on holidays and I need those files with me offline, and it will be a false positive. But on the other hand, it might be that my account was compromised and it's a data exfiltration attempt. Someone is downloading those files for malicious purposes. Next, typical use case, monitoring workstations for code execution, and the PowerShell execution can be detected. PowerShell in Windows environment is commonly used for privilege escalation, for lateral movement in those later stages after the initial compromise of the machine. And it would be good to monitor that as well. Detecting named pipes creation via tool like sysmon, which is also part of sysinternals previously mentioned by Dominic. Leveraging artificial intelligence and machine learning to enhance detection process, decision-making process, and perhaps connect those dots a little faster than a human would do it, or even detect things that we would miss because of this information overload. But for a machine learning algorithm, it's still not a problem. Now we know what a zero trust security model is with its core principles, with also some of its challenges that you may face when implementing it in your own company. So a few hints on a potential roadmap, something that could be useful if you decide to go forward with it. So first of all, you need to identify what you are protecting. So how the current environment looks like. What are the users? Where are they? What workloads do you have? Are those workloads on premises or in the cloud? Perhaps it's a hybrid solution. What do you really want to protect, and how the company operates? Where is the business value? What's the most important business process in the company? Knowing that, you can understand how it works and start working on a solution. If you are using a cloud provider already, then it's easier than if you are not using a cloud provider, because the migration to the cloud is a process on its own with its own challenges and considerations. So it will be harder if you are not in the cloud yet. If you are, then there are a lot of out-of-the-box solutions that can be leveraged. Developing policies, procedures, standards, internal documentation that everyone should follow. Finally, once introduced, once some simple solution is established, it should be monitored in order to, first of all, maintain it and then enhance it in time to be better and better. Benefits are definitely better visibility into various aspects of our environment, being data, assets, users, and their identities, risks that we are prone to. Compliance, another important factor, being consistent with some security standards and procedures. Finally, speed and in general performance enhancement of how our company operates, while costs are generally going down. If we are able to automate something, which was already mentioned, even incident handling, incident response, if it's automated, it would allow us to perhaps limit the number of SOC analysts responsible for incident response, and as such, reduce those operational costs and complexity. which, by the way, is a typical advantage of going to the cloud, where the workloads are more flexible. We can deploy something just in time with specific performance and destroy the resource once it's no longer needed. If you want to dive deeper into the theory behind the zero trust security, the most important resources are NIST standard 800-207 and also Microsoft's zero trust architecture. From my experience, Microsoft's take on zero trust is one of the best ones in the industry, and no endorsement here. I just think that you can't go wrong with following what Microsoft is suggesting in terms of zero trust. And now I think we have still a few more minutes, then I will share my screen and and show you some of the solutions that can be leveraged in the cloud, in the zero trust security model to increase the security posture. So here I am in the Azure portal. This is my own tenant, like my own company that I can manage. And the identity and access management solution I was talking about, at least in Azure, would be something called, would be a resource called Azure Active Directory. Here I am in my Azure Active Directory, where users, groups are created and can be managed along with the roles they have and the permissions they have. In functionality or in the goal, this is very similar to on-premises Active Directory, but this is not the same resource. How the Azure Active Directory in the cloud works and how the on-premises Active Directory works, these are totally separate mechanisms. Anyway, in the Azure Active Directory, I have my own user account, as you can see, and this account has some details about my identity. Not much is filled in, actually. It doesn't matter. What matters are my permissions. So first of all, I have the roles. And in this tenant, in this Azure Active Directory tenant, so like my company, I have a global admin role. This is the only account in the tenant, so I need to have this global admin. In a real company, 1, 2, 3 people perhaps would have this global administrator role, as this is the most the role with most permissions. As a global admin, I can do absolutely everything within the tenant. So this shouldn't be given out freely. This should be restricted only to those who actually need it. Other than that, I have some Azure role assignments in the subscription, and here you can see that on a specific resource, on a specific virtual machine, I have an owner role. Similarly to this global admin, an owner role is the almighty role that let's say the highest privileged role that you can have on a resource. However, in a real company with more accounts, you would also fine tune it. Some people would have a contributor access. Some people would have only a reader role, so read-only access to the resource. So that when their account is compromised, they can't do that much. So that's how it works. We can navigate to the resource, explore some of the settings. One of the settings here under networking are open ports and like an integrated or the firewall rules enforced on the network card, network interface. One of the rules, if you can see, is allowing any traffic on the 3389 port, which is a port for RDPing into this machine. And this is something that is allowed on purpose so that I could RDP to this machine from anyone everywhere else in the world. However, this traffic should be monitored. and is monitored in this environment to detect perhaps a malicious action that is taken if someone is able to successfully log in. Everything I'm doing here in the portal is actually an API call under the hood. If we open developer tools here in Chrome under the network tab, if I open one of those API calls that happened here, you will see that the authorization and authorization mechanism here is the bearer token. If we grab this token itself, go to the JWT website, we could paste it here and actually see what information is stored inside the token. And here we see the type of the token standing for JSON Web Token, the algorithm that was used to encrypt it. But the payload is the most important thing. We have the audience, so the resource that I am allowed to talk to because I have this token. Some details about me, so about my account, so my email, name, my IP address, other details. But also we have a expiration time in milliseconds, in seconds. I'm sorry, in the Unix epoch time. If we were to decode this timestamp as well, we would see that it's valid for roughly an hour, not even an hour from now. And if I were to sit idle here in the portal and then do something in an hour, my session would be invalidated in the meantime. My token wouldn't be valid anymore. I would have to log in, which is authentication and authorization process happening again. Even if I were to share this token with you, you could then impersonate me, do some API calls to Azure as me. However, it only would be valid for an hour, which is a good practice and an element of implementing zero trust security as well. And on that note, showing you how it also can be done in practice, I would like to end my talk. Thanks a lot for listening. If you have any questions, then please put them on the chat. I will answer those. Let me take a look. Is the location-based MFA policy compliant with zero trust model? Yes, this is something that, let's say, you could implement, and it is advised to implement when enforcing or when rolling out a zero trust model. Definitely.
Is a trust location, if trust a location, then it's not a zero trust. Yeah, but no question.
Okay, here I can answer. Actually, that's not necessarily true. And the location based or the location here in this context would be used to determine whether or not to enforce an MFA policy, and still it fits the principles of zero trust.
Okay.
And the rules themselves can be more elaborate. It can be location, it can be the device we are using, it can be when was the last time we logged in, when was the last time we logged in from this device, things like that. Oh, and other activity on our account, whether or not we were part of a security incident recently, and now we are logging in from a location known for malicious actors. So these rules, those conditions can be more elaborate than that.
Okay. So no more questions. I'd like to Thank everyone for being with us through this few hours, and maybe see you on the course, on some training, maybe see you on some labs. And thank you, Tomasz, for your presentation, of course.
Thanks.
Bye.